All right, so the only problem solving request we had for today was for homework 14 on section 4.1 problem 2. And so in my Blackboard, it's given by find the Laplace transform of f of t equal to t plus 2 squared. So we're trying to find the forward Laplace transform of t plus 2 squared is the problem. And I have pulled up on the side here the worksheet that we had to start this section, because we'll be needing some of these things to work through it. But if you kind of look at the worksheet, we only know Laplace transforms for pretty simple functions, and t plus 2 squared isn't so simple. So our approach for this whole section is kind of to simplify, factor, separate out fractions however we need to in order to turn the thing inside the Laplace transform into a combination of functions that we know how to take the Laplace transform for. So in this case, what we've got is that L of t plus 2 squared is going to be the same as L of t squared plus 4t plus 4, since t plus 2 squared is just going to be, we can find it with like FOIL, t squared plus 2t plus 2t plus 4. So that's how I got that first line right there. And then after we multiply it out like that, remember that the main property we're going to keep using through this section is this linearity property right here, which is that Laplace of linear combinations is the linear combination of Laplace. So we can always break up things that are added, we can pull constants out front, anything we need. So for us, that means that this is going to become L of t squared plus L of 4t plus L of 4, for example, just applying the addition part of the linear combination. And then we can see that we actually don't know like L of 4t, but we do know L of t by itself, or we don't know L of 4, but we do know L of 1. So we're also going to have to pull out the constant numbers that we're seeing here. And when I was doing the addition, I just, pulled it outside the Laplace. Same thing when I have multiplication by a constant number, I just pull it outside. And then this step right here, just important to note that like 4 is the same as 4 times 1. So I pulled the 4 out front and then left the 1 inside the Laplace right there. And then from here we can go ahead and start trying to apply the transforms that we've got on this table of some basic functions. So the easiest one right here is L of 1, I'm told, is 1 over s. So I can go ahead and just put in 1 over s for L of 1. But then for these other two, I have to do a little bit more work. So I'm told L of t to any power is n factorial over s to the n plus 1. So in this case, for the first one right here that I've got, that would be the case where n equals 2. So I've got t squared, t to the second power. And so following this formula, I'm just going to do 2 factorial over s to the 2 plus 1. So you just look at the power t, whatever n you've got, put factorial on top, and then divide by s to 1 more power than that. And then I'm going to do the same thing here with L of t. In this case, n is 1. T is the same as t to the power 1. And so I'm going to have 1 factorial over s to the 1 plus 1, applying that formula again. So then just putting in the factorials, you multiply down all the numbers. So I'm going to get 2 over s cubed plus 1 over s squared And then sort of moving the 4 back on top of that fraction, in that last term I'll have 4 over s. And I think this is my answer for this problem. I'll go ahead and try putting it in just to make sure though. So I've got 2 over s cubed plus 1 over s squared plus 4 over s. And then I'm going to try. Oh no, I got it wrong. All right, let's see what I did wrong. T squared plus 4t plus 4 looks fine. Oh, here's where I went wrong. When I did this part right here, I dropped off my 4. So I just have to make sure that I drag that all the way down as I'm working through it, and then I end up with 4 in the numerator of that term. So the issue I had just now was that I forgot to copy that 4 down, is all. In this section, it's easy to make lots of silly algebra mistakes, so we just got to be careful. But then that's the right answer. So if you're getting the wrong answer on this one, it's probably a mistake like the one I just made. Go ahead and go back and check. Make sure that you multiplied that out right is probably the first place that issues happen. And then make sure that you're using the right n for when you do the inverse Laplace, the forward Laplace, and then you should be good. So I'm gonna end this video and get it posted. Good luck everyone on your homework tonight.